All right, so what we're going to do is we're going to use properties of radicals to simplify expressions. We're going to simplify the expressions by rationalizing the denominator, and then we're going to perform operations with radicals. So that means we're going to add, subtract, multiply, and divide. Okay? All right, so definition. The definition of a radical expression is an expression that contains a radical. So some examples would be 2 square root of 5 negative square root of 13, or maybe 5 square root of 23 over 3. Notice these three are all different. The number under the radical, so this is your radical, that's a symbol, and the number underneath is called the radicand. Okay, so this would be 2. 2 is your regular coefficient. Radical is the square root symbol, and then 5 would be the radicand. So when you are simplifying them, these are the 3 rules you have to follow. If you don't follow these rules, then your radical is not simplified. So the radicand, remember, is the number underneath, has no perfect square factors other than 1. The radicand has no fraction, so you can't have a fraction, and the denominator cannot have a radical. So for example, here, when I'm looking at negative square root of 20, what I want to do is reduce this into simplest radical form. So this one would follow the first rule because there is a perfect square. All right. So this one is going to follow. So basically what I want you to do is I want you to make 2 square root symbols, 2 radicals underneath 20. Make 2. And then we're going to bring the negative sign down because it is part of the problem. So now I want you to think about 2 numbers that will multiply together to give you 20, but one of the numbers you're thinking of has to come from your list. Okay, some of you are going to say 10 times 2, but 10 and 2 are not in your list. Remember, you've got 1 squared, which is 1, 2 squared, which is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So since 20 is the number I'm looking at, 16 would be the number I would start with. 16 will not go into 20 evenly, will it? Will 9 go into 20 evenly? No. Will 4 go into 20 evenly? How many times will 4 go in? 5 times. So now I have this negative, and what is the square root of 4? It is 2, and the square root of 5 is a decimal, so I'm going to leave it alone. This one says that it cannot have fractions. Well, notice this has fractions. So what you do is you separate it into the square root of 34 and the square root of 3. You can't have a fraction as a radicand. Now it says I cannot have a denominator, my denominator cannot have a radical. Now I have a radical. All right, so this would not be allowed because it's not in simplest form. So here we're going to put it says determine if it's in simplest form, and we're going to say no, because there is a radical, is a fraction under the radical. A fraction under, that's messy, the radical. Now this one, is this one in simplest form? No, because it says there cannot be a denominator with a radical. So no, because there is a radical in the denominator. You have to be able to identify because there is a radical in the denominator. All right, I'm just going to put denom because I'm running out of space. So next part, So using properties of radicals, so the first thing we're going to do is we're going to use the product property. The product property says to take your radicand and we're going to separate it into two pieces. So remember our list, we've got 1, 4, 9, 16, 25, 36, 49. I'm just going to go to 49 because 45 is close to 49. But since 49 is bigger, I don't want to use 49. So now think about, from the list, will 36 go into 45 evenly? Will 25? Will 16? Will 9? So 9 will go in how many times? 5 times. What is the square root of 9? And then the square root of 5, since it's a decimal, you leave it alone because no decimals are allowed today. So that is your answer, 3 square root of 5. So that's all you have to do. Refer to that list and then use those numbers to simplify. Because these we know, we know these. Anytime you're asked what's the square root of 9, you know it's 3 because you know 3 times 3 equals 9. So let's do 24. So let's break it into two numbers. So looking at our list over here, 25 is closest, but it's too big. So let's look at 16. Will 16 go into 24? Not evenly, it won't. Will 9? Will 4? So how many times will 4 go in? 6 times. What's the square root of 4? 2. And the square root of 6 is a decimal, so you leave it alone. You always want to write the perfect square first because that's going to be your whole number when you take the square root. All right, in this one, we have a -2, and then we take the two numbers, okay? Because the square root of 48 is the one we're trying to split, but that -2 is still part of the problem. So going back to our list, 49 is too big. Will 36 go in? Will 25 go in? Will 16? Test it. You have a calculator. What is 48 divided by 16? So that means 16 times 3. You want to use the biggest perfect square or else you're going to double your workload. Don't work hard, work smart. Okay, so now I've got this -2 times, well, what is the square root of 16? 4. And then I have the square root of 3, which is a decimal, so I don't bother that one. What is -2 times 4? It's -8. Square root of 3 is my final answer. We have a negative out front, bring it down. Separate the 200 into two radicals. What is the biggest number from your list that will go into 200? 100 will go in 2 times. So negative, what's the square root of 100? 10, and the square root of 2 is a decimal, so you leave it alone. The square root of 36. This one is a perfect square. We already know this one, so you don't have to do all the extra work. If it's a perfect square, then let it be a perfect square and move on. Okay. Now we're going to do our quotient property. So the first thing you want to do is separate 6 and 49. So now the square root of 6, if you remember right here, we said that it was a decimal, so you let it be. Don't mess with it. If it's a decimal, leave it alone. And what is the square root of 49? 7. There is your answer. You want to get that square root out of the bottom. And if it's a perfect square, then it's easy to do. All right, so let's try this one. So you separate them just like we did with our fraction or with our multiplication. I'm going to separate these two. So the square root of 3 is a decimal, so I'm going to leave it alone. The square root of 4 is 2. Same thing on number 9. Separate them. The square root of 23. Well, since 23 is a prime number, then you leave it alone. Prime numbers will not simplify. The square root of 9 is 3, and then you leave it alone. All right, so now, what if we're going to add or subtract? When you are adding and subtracting radicals, you have to make sure that they have the same radical. It's just like adding like terms. So I have an x here and I have an x here. So 3x plus x would be 4x. Y'all know how to add those. If you had 2y plus 7y, 2y plus 7y is 9y. Okay? Because you're just combining like terms. When you're adding and subtracting, it is the exact same thing. Do you see how you have 3 square root of 5 and there is 1 square root of 5 right here? So it's 4 square root of 5. Do not add the square roots together, just like in the activity that we did. You can't add them together. But you can add the number, the coefficient that's in front, as long as they're like terms. So, for example, if I had 3 square root of 5 plus 7 square root of 2. This is a 5 and this is a 2, so there you cannot simplify it. This is simplified. That's it. This is simplified. Okay? Just like if I had 3y plus 7x. I can't add those together because they are not like terms. Okay? Not like terms. All right, so let's look at this. We have 3 square root of 7 plus 2 square root of 7. Since they both have a square root of 7, then you just add the number, keep the square root of 7. The next one, they're both a square root of 3. And it tells me to subtract. So what is 10 minus 7? So 3 square root of 3. You do whatever it tells you to do with the whole number, and you leave the square root alone. All right, on number 12, I have the square root of 12 and the square root of 3. Well, this looks like they're not like terms, doesn't it? But sometimes you have to double check that your square roots won't simplify first. So for example, this is 3, and then if you think about 12, what is 2 numbers that multiply together to get you 12? 4 and 3, because 4 is in our list, isn't it? So this would be 3 times 2 square root of 3. So that would be 6 square root of 3. So this number right here, your 3 square root of 12, it reduces to 6 square root of 3. Now I can add that 2 square root of 3 to it, because now they're like terms. So sometimes you have to simplify first. I could not simplify the 5 and the 2 on my other example because they're both prime numbers. 5 and 2 are both prime. They don't simplify. So draw a rectangle underneath this problem because it says to find the exact perimeter. When it says exact, anytime you have a question on an assignment and it says find the exact, that means do not give me decimals. Decimals are approximations. They are not exact. So since they're asking for exact, then that means I'm going to have to use my radicals. Okay. So it says that the width is 4 square root of 5. Well, that means this is 4 square root of 5. And that means this side is 4 square root of 5 because remember rectangles are parallelograms, the opposite sides are congruent. And then it says the length is 5 square root of 9. So that means this side is 5 square root of 9. So how do you find perimeter? Well, isn't perimeter just add up all 4 sides? So the perimeter would be 4 square root of 5 plus 4 square root of 5, because there's 2 of them, plus 5 square root of 9 plus 5 square root of 9. And now I can add like terms. So the perimeter is 8 square root of 5 because there's 4 and 4. And then there's 10 square roots of 9. But right away, I noticed that the square root of 9 is really what? 3. So this is really 8 square root of 5 plus 10 times 3 because the square root of 9 is equal to 3. So the perimeter is 8 square root of 5 plus 30. And that is your final answer. Okay, they didn't give us dimensions, so we don't have to worry. So that is your exact answer. It's ugly and it looks weird, but that is your answer. All right. So now we are going to multiply radicals. I didn't leave a page off, did I? All right. So when you are multiplying radicals, this is how it works. You multiply the numbers that are outside together. So like 2 times 5. Well, what is 2 times 5? 10. And then you put your square root. And then you multiply the numbers that are underneath. What's 3 times 2? 6. So there's your answer. Remember, the square root of 6 is a decimal. So you leave it alone. All right, so let's look at 14. So I have 5, and there's really a 1. Anytime you see a square root by itself, that means there's a 1 in front. So what is 5 times 1? And then 2 times 6. But remember, 12 will simplify, so I've got to simplify this. And we said a while ago that 12 was 4 times 3. So this is 5 times 2. Square root of 3, so 10 square root of 3. Okay, you have to simplify to the very end. All right, 3 square root of 11. What kind of a number is 11? Does anybody know? Huh? It is prime. Since this is prime, this is your answer. Done. You can't simplify 11 because it is prime. All right. Number 16. There's a 1 in front. So what is 1 times 4? 4. And then square root. Now what's 6 times 12? 72. Well, now the 72 will simplify. So I'm going to have 4, and then I'm going to separate the 72 into 2 numbers. So looking at your list, what is the largest number? 64 was closest to it, right? Will 64 go in? Okay. Will 49 go in? I'm hearing 36 and 2. Does everybody agree with 36 and 2? So that means 4 times. Well, what is the square root of 36? 6. So 4 times 6 is 24. Square root of 2. And there's your final answer. You have to keep simplifying them until they don't simplify. You cannot leave it in this form or it will be a wrong answer. All right. 3 times 4 is 12. 8 times 5, 40. So now I check my list. So I've got 12 and 40 will break into what? Well, there's 36 is the biggest number, but will it go in evenly? Will 25 go in evenly? 16. 9? 4. Well, 4 will go in 10 times, won't it? So this is 12 times 2, square root of 10. The square root of 10 will not simplify because it's 2 times 5. They're not the same number. So I've got 24, square root of 10. So draw a square, and we're going to find the area if the side is 3 square root of 4. Remember, in a square, all 4 sides are the same. But remember, area is length times width. Or some of you may remember it as side squared. So this is also 3 square root of 4. So you take your length is 3 square root of 4, times your width, which is also 3 square root of 4. What is 3 times 3? And 4 times 4? And what is the square root of 16? 4. And what is 9 times 4? So your area is 36. All right. So now we're going to do what's called rationalizing the denominator. Rationalizing the denominator sounds scary, but it is very, very simple. So if you'll remember at the very beginning of our notes, we had that question, and it was like, was the square root of 34 over the square root of 3? And we said this was not in simplest form because there's a denominator and it has a radical. So what we're going to do is rationalize that. In other words, we're going to get rid of it. All right. So this is how you work it. So you take your number. So if it says to simplify 10 divided by the square root of 7, to rationalize the denominator, all you're going to do is multiply the top and the bottom by the square root of 7. Why the square root of 7? Because that's what's in the bottom. Because when you multiply a radical by itself, it's just the number. So like if I have the square root of 1,000,000 times the square root of 1,000,000, my answer is, it's just 1,000,000. Ooh, that's a horrible M. The square root of 5 times the square root of 5, 5. The square root of $1 times the square root of $1 is $1. Okay? So when you're rationalizing the denominator, what you're doing is multiplying the denominator by itself to make the radical go away. So now what happens when you multiply across? You get 10 square root of 7, and then you get 7 times 7, which is 49. So you have the square root of 49. Well, what is the square root of 49? 7. So this is your final answer. So multiply across, reduce the bottom. So let's do the first one. We have 3 divided by the square root of 5. So you're going to multiply the top and the bottom by the square root of 5. So multiply straight across. So 3 square root of 5. And then you get the square root of 25. So you get 3 square root of 5 over 5. You cannot divide a whole number into a radical. Numbers go with numbers, radicals go with radicals. So don't try to simplify these two because you can't. All right, what's in the denominator on number 2? So we're going to multiply the square root of 10 and the square root of 10. So go straight across. So I got negative 14 square root of 10. And what is the square root of 10 times the square root of 10? It's the square root of 100 because 10 times 10 is 100, right? So now I've got negative 14 square root of 10 divided by 10, because the square root of 100 is 10. But what do you notice about the 14 and this 10? What do you notice about these two numbers right here? They're both even. They will simplify. Basically, it's like saying negative 14 over 10. So 2 will go into this 7 times. 2 will go into this 5 times. So you get negative 7 square root of 10, because the square root of 10 is untouched, over 5. You still have to reduce your fraction just like normal. But now you have a square root there. Just leave it alone. Okay. In this next one, we're going to separate them. So you have the square root of 3. That's an equal sign, not a multiplication, sorry. Over the square root of 8. To rationalize, I'm going to multiply by the square root of 8. So since both numbers are under the radical, I can multiply them together. So what is 3 times 8? 24. And what is 8 times 8? 64. So what I do know is that the square root of 24 over 8, because the square root of 64 is 8. But, there's always a but. I have to simplify the 24, because remember a while ago on another problem, it was 4 times 6. So we still have to simplify this. So what I'm going to do is okay, 24 becomes 2 numbers. I'm going to leave the 8 alone. So we said it was 4 times 6, right? Are y'all with me? What is the square root of 4? So, and the square root of 6 is a decimal, so remember we leave it alone. And now the 2 and the 8 will simplify just like the 14 and the 10. 2 will go into itself once. 2 will go into 8 4 times. So I get the square root of 6 over 4 as my final answer. Sometimes they'll simplify a lot faster. Sometimes you have to simplify fractions. But you guys learned how to simplify fractions in elementary school, so if you don't remember, then you need to practice that. Okay? It's not something that you just recently learned. All right, last one, we have the square root of 7 over the square root of 32. So I'm going to simplify this by multiplying the top and the bottom by the square root of 32. To save myself a step, what I have noticed from the example in these 3 is if I multiply these 2 numbers in the bottom, it's always just the number. Have y'all noticed that? So what I'm going to do here is I'm going to get my calculator and I'm going to multiply 7 and 32, which is 224. So I get the square root of 224. But that bottom number, that's 32. Because I know when I multiply these 2 together, the pattern shows me that it's always just the number. The square root of 5 times the square root of 5, 5. The square root of 10 times the square root of 10, 10. The square root of 8 times the square root of 8, 8. So every time I multiply the radical by itself, it's just the number. So to save myself a step, because we want to try to eliminate as many steps as we can, right? So now I'm going to separate the 224. So I need to find 2 numbers that will multiply together to give me 224. But remember, it has to be a number from my list. So 224, and we only went to 144, but that list goes on, doesn't it? So you had the 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. So 13 squared is 169, 14 squared is 196. 15 squared is 225. So I'm looking for 224. So that would be my biggest number. So I want to start here. So will 196 go into 224? We're trying to find a number that will go into 224, right? All right, will 196 go in? Not evenly. What about 169? 144? So 224 divided by 144. What do you get? So 224 divided by 144 is a decimal, so it's not that one either. 224 divided by 121. A decimal. 224 divided by 100. 224 divided by 81. 224 divided by 64. 224 divided by 49. 224 divided by 36. It's definitely not going to be 25 because it ends in a 5. So now if I divide by 16, I find out that it's 16 times 14. So this is 4 square root of 14. So sometimes it takes a few tries. So I'm going to go back here. So this is going to be 16 and 14. So we said that is 4 square root of 14 over 32. Now the 4 will go into itself once. It'll go into 34 8 times. So my answer is the square root of 14 over 8. Reducing these sometimes will take the longest amount of time, but it's just because they're tedious, not because they're hard. Because you're using the numbers from your list. If you just use that list, then you'll be able to get your factors. All right, so what I want you to do is try these on your own.